Brilliant. Okay. Yes. So thank you very much for the invite to come and talk to you all today. My name's Jason Evans. I'm currently the Open Data Manager at the National Library of Wales. And I started working probably about 10 years ago with building this collaboration with Wikimedia. And it started off very much focused on Wikipedia and Wikimedia Commons, sharing openly licensed images. But very quickly, I I saw the potential in Wikidata to be utilized for cultural heritage projects, and that's really what's kind of led us to where we are today. So my talk is going to consist of a brief intro or refresher on Wikidata itself, and then I'll talk a little bit about the development of Wikibase as a separate product and how that's being implemented, and give you some examples of Wikibase instances, and then talk about the Wikibase Cloud project and our Wikibase Cloud instance specifically, which, as Marco said, we're using to host name authority data. And it's kind of a bridge between Wikidata and our internal catalogs and systems. So let's start with the Wikidata basics. So Wikidata is a linked open database, and it was originally conceived to manage knowledge stored in Wikipedia as data. I think one of the first kind of conceived applications for Wikidata was to pull together different language editions of Wikipedia articles and have them stored under one entity so that you knew what you were dealing with when you had a Wikipedia article in one language. It's connected to all the other language editions of that same article. But like Wikipedia, Wikidata is completely open, and the community has full control over the type of content that's created, but also the data structure, the ontology. They have control over the properties that are created and policy around what's in scope and what's not. So very quickly, Wikidata began to grow into something much bigger as a platform for hosting data about everything, whether that be something on Wikipedia or not. So you can see from the example on the screen that data items in Wikidata consist of a human readable label, so Douglas Adams in this case, a unique QID, which is Q42 for Douglas Adams. You can have human readable descriptions and alias also. And then the real sort of power of Wikidata is the statements, adding statements to an item that describe in structured data what that entity is. So in the example statement, we can see Douglas Adams was educated at St. John's College. And that is what forms a statement, or a triple, if you like. And you can also qualify and reference all of those statements. So this is a kind of slightly more technical diagram of how Wikidata works under the hood in RDF. So this shows a fairly simple but really flexible concept, and this is what allows for very granular data to be used on Wikidata to describe things into very fine detail. And understanding this structure is really important when it comes to querying the data and trying to actually understand how to get that knowledge back out of this massive data set. So again, you can see here you have the kind of item or entity, if you like, which has a unique QID and a unique URL that's based around that unique identifier. P is the property, so that leads you to your main kind of statements that you have for each item. And then you have things, if you see coming down from the statement in the middle there, you have PS and PQ. So PS is the source or the referencing node, if you like, and then QPQ is what allows you to add qualifiers to statements. So that references and qualifiers are almost like another triple nested within a triple. So yeah, for example, you can, if you have a statement that says someone's occupation is prime minister, then you can have another qualifying triple that says the occupation was prime minister from this date, from this start date, and another one saying the end date, for example. So you can get really granular with the data. Yes, so that's the kind of more technical overview. So Wikidata from those early days back in the early kind of 2000, like 2005, I think it started. It's grown at a crazy rate. It's got very big very quickly. There's over 100 million items now in Wikidata, and those are made up of billions of triples. And it includes data on everything from people and places and species to events, concepts, genomes. Like Wikipedia, it's really its goal is to encompass the sum of all human knowledge. Yeah, so like pretty much everything's in scope. Now it's very difficult to actually query Wikidata in its entirety. And we'll get into some of the more kind of challenges with scaling Wikidata shortly. But just to look at some of the relevant content for the GLAM sector, or galleries, libraries, archives, and museums, you can see there are 41 million scholarly articles in Wikidata. So that's like 40% of the entire size of Wikidata. That's a huge amount. There are over 5 million paintings, 10 million people, 12 million places. So there are huge amounts of content there that are of value to the culture sector. But you'll also see one of the kind of slimmer lines at the top there is GLAMs. So there are actually 250,000 sort of cultural heritage institutions listed in Wikidata. And really that kind of gives you a sense of the scale of the issue here. If all of those institutions decided they wanted to share all their collections to Wikidata, you suddenly start to run into massive scalability issues. There are, each organization might have millions of catalog entries, millions of items. And so Wikidata would start to struggle with all that data very quickly. So this is something that the team at Wikidata are concerned about. They currently use BlazeGraph to power their query service, and it's already really struggling. They're looking for new ways of being able to speed up that query service because it just fails. It times out so frequently because of the resources needed to query such a huge data set. So as it gets bigger, Wikidata is also getting messier. So there are currently 11,435 properties for describing things on Wikidata. That's quite a lot. And of course, the more properties you have, the more chances are that you've got quite kind of ambiguous and similar properties that it makes it easier for people to make mistakes and for things to vary in the way they're described, because there are all these properties, and unless you know Wikidata very well, there are risks that people are describing things in the wrong way, and so it gets messy. There are also a growing number of duplicate items on Wikidata as individuals and organizations jump on this bandwagon of uploading all their data to Wikidata without doing kind of thorough checks to see whether the entities that they're creating already exist. So this is particularly true for people and places. And even with 11,000 properties for describing things, sometimes it actually proves too limiting, and it's not possible to describe things correctly within the data model. So things such as oral traditions, spoken histories, alternative territorial entities. Modeling the history of North America, for example, looks very different from a Native American point of view than from a kind of modern Western point of view. And these two histories are often very difficult to model side by side within the one structure. And we've got the same issue in Wales, whereby Wikidata doesn't recognize Wales as a country, only as a constituent part of the United Kingdom. And it's the same for Scotland. So people's nationality can't be Welsh. And if you're saying a place is in Wales, there's a property for country, but you can't say that the country of the place is Wales. You have to say United Kingdom. So again, if you think about that in terms of the Native American issue, the nationality of Native American people cannot be the nation of their people. It has to be the United States of America. So there are issues with trying to have this one data set that caters for all data. And this is where Wikibase comes in. So Wikibase provides flexibility in terms of data modeling and helps build a more robust infrastructure around Wikidata. So when we talk about Wikibase, we're essentially talking about an empty version of Wikidata. So Wikibase is the stack which powers Wikidata, and the Wikimedia Foundation have begun releasing all the elements that you need to build your own Wikibase in a way that makes it quite a lot easier to do so than it used to be. And what you get is something that very much feels and looks like Wikidata. It benefits from a lot of the tools developed for Wikidata, such as the query service, the MediaWiki API, OpenRefine support, upload tools, Elasticsearch, all the rest of it. And one of the kind of proposed solutions for this rapid growth of Wikidata and the need for flexibility in the data ontology is the use of multiple Wikibase instances as a kind of decentralized network. And there are a number of cultural institutions who are investigating this or already using Wikibase in this way. So BNF, the National Library of France, actually funded a study a year or so back to look at using Wikibase as their main library catalog. And I think Library of Congress has already been developing their own Wikibase, as well as a number of European institutions for managing various elements of their data. And the idea is that a network of Wikibases can exist where you can have flexibility with the data structure, with the licensing of the data, for example, but they are still interconnected through a common overarching data structure and federated querying. So Wikibases that are aligned, at least in part, to Wikidata also connect back to all that wealth of data that we know is already in that wiki ecosystem. So it can benefit from all that data that already exists. So currently, federated query works between any given Wikibase and Wikidata, which is really powerful in itself. But federation between Wikibases is something that the team is still working on exactly how that's going to be possible. So this is an example of a website that is powered by a highly customized Wikibase. The enslaved database has over 100 million, over 1 million entities. And underneath this is powered by a customized, locally hosted Wikibase with lots and lots of items and just a few kind of key relational properties linking them together. But this has little or no alignment to Wikidata. And this just kind of shows that people are actually using this as a standalone tool, and don't necessarily plan to link in to the kind of wider wiki ecosystem at all. Now, Wikibase is also being used to facilitate structured metadata on Wikimedia Commons. So for those that don't know, Wikimedia Commons is a massive repository of openly licensed images, sound, and video. And it's where most of the images that you see on Wikipedia come from. So this is hosted on MediaWiki, and until recently it relied on a kind of clunky and very messy categorization system and a simple text search for sort of organizing and searching all the content that they had. So what they've done is they've tried to structure much of that data and store it in a separate Wikibase. And they also allow you to tag things that are depicted in the images on Commons using Wikidata as a vocabulary, and then all the data is stored in this separate Wikimedia Commons Wikibase. So this is an example of a use of Wikibase that is much more heavily aligned to Wikidata. And of course, this means that it's improved search and discovery on Wikimedia Commons. It now has its own Sparkle endpoint, and the API is much more powerful. Yeah, so this is a great example of an implementation designed to enrich data using existing data from Wikidata. And it's very much more along these lines that we've gone with our Wikibase also. So this brings us to Wikibase Cloud. So until recently, Wikibase had to be kind of built up locally, and you had to kind of pull in all the modules and everything that you needed to make it work. So obviously for very technically competent people, that's fine. But what the Wikimedia Foundation have done is they've packaged the whole thing up into a cloud service where you can request a Wikibase and they fire one up for you, and it all comes pre-packaged. It has slightly less flexibility than if you host it yourself in terms of modifying it and sort of making changes to it, but it works very well as a package, and Wikimedia are kindly hosting this for free as well. So there's no cost involved in hosting, having your own Wikibase. And of course, it benefits from all those tools. It's got an upload tools. It's got its own Sparkle endpoint. Elasticsearch is built in, etc. So this drastically reduces the barrier to entry and the cost of having your own Wikibase. So here are some examples of Wikibase Cloud instances. There are actually over 300 active deployments, and this only came out of closed beta last November. So it's still quite early days. They're still ironing out some technical issues, but on the whole, it works really well. So you can see just in these are the kind of largest in terms of the sort of a number of items of the kind of cloud instances so far. You can see the NLW Semantic Name Authority Cymru dataset. That's our one that I'll be talking about shortly. But there's others like the British Library have used this for their Lord Chamberlain's Plays Index. But there's also here Wikibases that have been just set up by members of the public, and perhaps pull in data from Wikidata or some data set that they've been curating for years, and looking at hosting it on Wikibase. So again, there's a real mix of databases. Some are very heavily aligned to Wikidata, and others have kind of no intention of doing so at all. So before I talk about our Wikibase, I just want to mention another Wikibase that I'm developing as part of a TANC project. TANC is towards a national collection, and this is a series of projects funded by HRC that are looking at how the UK could pull together all their archive data into one place. So the aim of the project, this particular TANC project, is to look at how we can pull together data from community created archives. And a lot of the feedback, interestingly, that they've had in this project was that they were happy to share their data and for it to be part of a kind of union catalogue, but there was a lack of trust for just sending it off to somewhere like the National Archives and them just having control of it, and it not them having then no kind of say in the development of that data over time. So actually the Wikibase solution, where you've got the flexibility of being able to control and give administrative access to individuals or organizations, where the data can be continually developed and changed and added to over time, and where the community can actually have a say in the data structure as well, rather than it being dictated to them by sort of traditional archiving standards. So yeah, we're building this Wikibase for them, but I think this just kind of highlights that the benefits or the advantages of having a Wikibase go beyond kind of data quality and access. It's really about giving people a control and a kind of democratizing archive data. So then we get to our Wikibase, which I've named SNARC, so Semantic Name Authority Cymru. Cymru is just Welsh for Wales. So our Wikibase is to store name authority records. So basically a name authority record, this is an example of one. So items in our catalogue that mention a person or are created by a particular person get linked to a name authority record for that person. And I suppose that's kind of linked data in its most basic form. So you can see it contains basic biographical information, but of course, by making an alignment between this record and the item on Wikidata for Mary, Queen of Scots, you're going to get access to a whole lot more data because Wikidata already contains much more biographical information about her, and also it'll have identifiers on the Wikidata item for all sorts of other organizations that hold information about Mary, Queen of Scots. So you can see Wikidata kind of begins to be this kind of central hub where archive collections across different institutions all over the world are joined together. So in this process, we discovered that we've actually got lots of duplicate authority records. We've also got different catalogues that have different systems. So there are people that appear in different catalogues that don't talk to each other. So by aligning those to Wikidata, we're actually kind of creating a merge and really cleaning up our own data. So we wanted to build a Wikibase with enough data in it to be of value to researchers and staff as a kind of standalone tool, but aligned enough to Wikidata to be able to do federated queries and still be able to fetch, whenever we wanted it, additional data from Wikidata. So why not just use Wikidata and take out the kind of middleman of having your own Wikibase altogether, since we're already doing that alignment to Wikidata as part of this process? So Wikidata, we know, is hugely valuable. There's lots of rich data there. It's this kind of hub for cultural collections through the unique identifiers that organizations add to items. But as we start to think about round tripping our data and using Wikidata to improve our own services, there are a few considerations that we need to think about. So firstly, Wikidata, as we know, is huge. It complicates things, and data is often kind of used inconsistently, the structure of the data to describe things. And then in terms of access, anyone can edit the data or even change the meaning of properties on Wikidata at any time. There is a kind of community process to go through, but we don't have, as an institution, control over either the quality of the data or the kind of ever-changing structure of the data. Whereas when you have your own Wikibase, you're kind of in control of that data. You can do periodical checks and pull in and look for new data from Wikidata, but as we import data into our Wikibase, we're able to check it and make sure that it's standardized and to the standard that we want. And then we can be sure that any tools that we run off that data set work as they should. And then there's the language issue. So Wikidata has partial coverage in over 300 languages, whereas we're really focused in our data set in having complete coverage in English and Welsh. So as we imported bits of data that we wanted in from Wikidata, we were able to fill in gaps where there was no Welsh. We've obviously pushed that back to Wikidata, but it means that we can be sure that at any given time, all of our data is fully bilingual within our data set. And then, of course, there's the content. So Wikidata contains data about everything, whereas our data set is very focused on authority data for people and things related to people. So occupations, the languages that they spoke, the places. There's lots of places as a result of this because you want to be able to say where people were born, where they died, etc. So our data set, we wanted it to be more focused. And of course, what that means as well is that we can use our Wikibase as an endpoint where we can send our staff and our researchers, and they can search that data knowing that they're only going to be able to find relevant data from our collections. Whereas if you search Wikidata, they have to kind of cipher through all this other data that's there that isn't relevant to them. So this is a more technical model of how our database works. So we pull data from various sources in our catalogue, authority records, the Dictionary of Welsh Biography, other places where we have data about people. And we reconcile that to Wikidata. And we've used a lot of OpenRefine and some AI tools to help in that process of matching people up correctly to their relevant Wikidata items. And then that data gets pushed into our Wikibase, where, of course, we can have our own data structure. We can pick and choose which bits of data we want to pull in from our own catalog, what we want to pull in from Wikidata in order to create a record that suits our needs. And of course, from there, you've got the API and the query service. And as I was just saying, you can then use that as a landing point for our community to go and be able to find useful data. So this is the SNARC website. This is the main page. So you can see in the top right corner there, you have a search box, and you can, just like on Wikidata, you can search for something there and look at individual items. But you've also got, what we've also done is we've got links to a number of pre-written queries using the Sparkle endpoint, where people can, it'll do a live search of the database and they're kind of tailored to different kind of research needs. You can look up different elements of the collection and see different visualizations as a map or as a graph, etc. So currently there are 34,000 people in the data set. Most of those have an authority record in the National Library collection. We also decided to pull in from Wikidata where they existed, close family, so spouses, children, parents, just as a way of being able to start to build up family trees within our data set, because one of the things the alignment with Wikidata did was make us realize that a lot of the people in our collections are related in some way, but there was no way of showing that in our own data. So we've tried to utilize as much of that from Wikidata as possible. And then, of course, you've got the places. I mentioned that there was a lot of places, so 46,000 so far. So we actually tried to import pretty much everywhere in Wales that was in Wikidata into the data set, because those are likely, even if they're not being used at the moment to describe people, the chances are that they may well be at some point. So we wanted to bring in all Welsh places, and there's lots of things like universities and stuff from around the world as well, so that we can say where people were educated, etc. And the visualizations that you see are just an example of what we can do with the query service on the Wikibase. So the first visualization shows the types of places based on their frequency within the data set. So lots of cities, chapels, a very Welsh thing, universities, villages, etc. And the second one, the map there, that's we've asked the query service to show us all places in Wales that start with Llan. So there are rather a lot of those. So obviously in Wikibase, we can choose our own properties and we can dictate how they behave. So we really wanted to ensure interoperability with Wikidata as much as possible. So we haven't changed the data model that Wikidata uses too much, but it is drastically smaller because we only need a fraction of the properties that Wikidata needs, since we're dealing with such a kind of focused subset of the data. So there are a few differences to Wikidata. So if you're familiar with looking at a Wikidata item, there is an image property. And you can see here, we actually have a Wikimedia Commons media property, which is slightly different. And you'll see in a minute why, because we also have another image property that relates specifically to our collections. And then you've got this really important thing. So adding the Wikidata IDs to items is really important for keeping that alignment and being able to do that federated query. So you do this for properties and items. So basically saying this is the equivalent item on Wikidata for this person or this entity, whatever it is, and that keeps that alignment with Wikidata, and that's super important in our case. Yes, so I mentioned the image property. So this then is the NLW media property. So this is something completely different to Wikidata. And this allows us to list images in our collection at the National Library of the subject of this item. So this item in our Wikibase is for a person called Sarah Jane Rees. And these are the images that we have in our collection. So we've got a title and a persistent identifier that takes you to a IIIF image viewer. So this is something you can't do in Wikidata at all. If you wanted to do this in Wikidata, you'd have to create items for each of the images and then link them to the person by saying this image depicts this person. But we don't want to create a data set here of items in our collection. We want to create a data set for people and places. So we've kind of completely changed the structure in that area. It doesn't really affect querying and that alignment with Wikidata because it's something new. We're not reinventing something that's on Wikidata as such. This is specific to our needs, and it just shows how you can tailor Wikibase to suit the needs of your organization. And for places in particular, we work closely with the Welsh Language Commission that has a database of standardized forms of Welsh place names. And I've done a lot of work aligning those to Wikidata and to our database. So Wikidata, we can't kind of insist that Wikidata uses these standardized forms, but the National Library has made a decision that it wants to use the standardized forms of Welsh place names. So we can do that in our data set. So the labels that you see in our data set for things that are in Wikidata will vary slightly. And we have this source of name form property, which again is something that isn't on Wikidata, where we can say that the source of this form of the name has come from the Welsh Language Commissioner. And you'll see at the bottom there as well, country, Wales. So what we did here was we've used the country property in exactly the same way as Wikidata does, and we've kept the alignment, so our database treats the country property exactly the same as Wikidata. We've just changed the description of that property to include sovereign states and any nation, whereas Wikidata just allows you to add sovereign states. So that means we can say that places are in Wales. And here's an example of an entry for a person completely in Welsh, just to show that this is a fully bilingual data set. And that includes the interface itself. There's a language switch, so you can see the main page in English or Welsh. And most of the facets down the side there are also available in Welsh. So, as we know, Wikidata is quite kind of complicated. So when it came to the data structure, we really only needed to describe people and places, things like occupations and languages. So our ontology was always going to be a lot smaller, and we've kind of started by just kind of scribbling out a diagram of what we thought we might need. And so far we've got 78 properties for our data set, which is a lot less than the 11,000 on Wikidata. And this means that it's easier for users to understand the structure of the data, and it makes it much less likely that you'll see inconsistency in the way that things are modeled. And then we've got 4 kind of superclasses of items. So these are kind of loosely based on Wikidata superclasses, but they have been generalized. But then everything from the kind of second tier down all align perfectly to Wikidata. And we've got this kind of visual interface on the front page of the Wikibase where you can actually drop down and see the different types of items under each subclass. So you can see the occupations, etc. So if you look at subclasses on Wikidata, by the kind of 3rd tier, there are thousands and thousands of them. It gets vast very quickly. So what we've tried to do is simplify that data hierarchy. We've cut out subclasses that we deemed unnecessary for our needs. So on Wikidata, there are often 4 or 5 subclasses between university or school and educational institution. So what we've done for the SNARC database is we've cut out these. So actually, we just go straight from university to educational institution. And it's the same with cities. You know, we're not really concerned in our data set with the nuances of a big city versus a global city or a mega city. So we've done this to try and keep our data set simple, for people adding data, for people querying the data, and to keep it generally light without having to have hundreds of thousands of items, additional items to describe that kind of level of granularity that Wikidata does. However, as long as you align the parent class, so city in this example, to the Wikidata item for city, you can still get access to that really granular data that Wikidata has without us having to have it in our data set. So this is an example of a pretty short query in my Wikibase query service. So what I've done here is I've asked the Wikibase to return all instances of cities in our data set. So it's fetching all the cities that it finds. And of course, we just use that one city subclass for all of them. And also the Wikidata ID. So we've kept the alignment with Wikidata, so we've got access to the Wikidata ID from our data set. And then we invoke the Wikidata query service and say, now I want only megacities from this list. So the list that's returned at the bottom of this query is all the megacities in our SNARC database, without us having to actually have that knowledge in our data set. And this really is where that kind of federation between Wikidata and a Wikibase or multiple Wikibases comes in. So you don't have to keep replicating these vast ontologies to still be able to get access to that really granular data set that someone else has. So as I said quite early on, you can do federated query like the example I've just shown you between a Wikibase and Wikidata. That works fine. How exactly that will work between Wikibases is still being discussed. But I just wanted to show you in the settings when you set up your Wikibase cloud, you have this page here where you can map between properties in your Wikibase and the equivalent properties on Wikidata. And you can do the same with items as well. So this creates a map of key properties. So you say, well, P3 in my dataset is exactly the same as P1630 in Wikidata. And this allows that tools built for Wikidata, like OpenRefine for the reconciliation service, can handle the data properly. It treats your identifiers as your properties, sorry, as it would treat the ones from Wikidata. And there are certain properties on Wikidata, for example, that have kind of special functionality, like the formatter URL, which creates kind of hyperlinks from identifiers. If you align your property for a formatter URL in your Wikibase to the Wikidata one, it should make it behave in exactly the same way, so you get the same functionality. And I think probably the way that federation between Wikibases will work will be through this kind of mapping of properties. I think that's really probably the only way it can work. So if you make a mapping alignment either to Wikidata or some kind of predefined maps for different types of data, then you'll be able to do that federated query. But yeah, we'll see how that goes. I think they're going to be working on it this year. And then just to finish, just kind of to show you that I've also been trying to, as we've been building this Wikibase, I've been trying to document exactly how properties should be used, and the types of properties that are suitable for people and places, for example, just to try and make sure that as we expand out, the idea is that we can allow trusted partners access to this, to edit the data, to enrich the data, but we want to make sure that it's as well documented as possible so that people know how to use it properly and consistently. And that's it. That's the URL of the SNARC database if you want to go and have a little look. But that's all I've got. So thank you very much, and happy to try and answer any questions.
Thank you very much, Jason. It's great. Let me just stop the recording here.